Hello everyone. Today we take one of the most critical and challenging tasks for any statistician, the art of translation. How do we take a broad clinical curiosity and turn it into a precise, analyzable statistical question? To do this, we must act as bridge between two very different languages. Clinicians speak the language of patients. They ask about feelings, cues, and general effectiveness. Statisticians, however, speak the language of data. We care about delta, thresholds, and distribution. Success depends on translating that qualitative clinic feeling into a quantitative statistic facts. So, how do we perform this translation? We use a specific formula. Every clinical question must be refined into an endpoint. An endpoint is not just a variable. It's a formula of three components: the variable, the what, the time point, the when, and the metric, the how. If your endpoint is missing any of these three, your trial design is incomplete. Let's look at the first component, the variable. The variable is what? Are we measuring blood pressure, pain, or survival? When selecting a variable, you must check for two things: sensitivity and reliability. Is it sensitive enough to show the drug effect? And can it be measured consistently across multiple doctors and hospitals? The second component is the time point. The when is just as important as the what. For example, if you measure blood pressure too early, the drug hadn't reached its peak. If you measure too late, you might lose patients to drop out. Picking the right time point, like week 12 or week 24, is a strategic decision based on drug pharmacology. Finally, we have the metric. The metric is the how. Do we want to look at the absolute change from baseline, or percentage change, or perhaps a responder rate, which tell us how many patients improved by a certain amount? Each metric has different statistical power and clinical meaning. Let's look at a real-world example: pain relief. A clinician might say, I want to see if the drug improves pain. As a statistician, you translate that into change from baseline in VAS score at week 4. If they want to improve relief, you might define a responder as someone with a 30% reduction in pain. The translation clarified the goal for everyone. Choice of metric directly impacts your study power. As this chart shows, continuous variable like a pain score generally provide more sensitivity and statistical power than binary yes or no endpoints. If you choose a binary responder rate, you will likely need a much larger sample size to achieve the same confidence. Watch out for these non-analyzable traps. Never accept vague time point like at the end of study. This is a disaster for data cleaning. Also, avoid subjective metrics without a validated scale. If the metric isn't clear, the data will be noisy, and you will fail to reach significance even if the drug works. I want to leave you with a core principle for your career. If a clinical goal cannot be written down as a mathematical formula, it is not a statistic objective yet. Push your clinic colleagues to be precise. Precision in question leads to precision in the results. This translation must carry over in your SAP. The statistic question in your SAP must be a direct mirror of the clinical objective in the protocol. Any gap between these two documents is a major red flag for regulatory reviews. Full consistency is the key to a clean submission. Mastering this translation is the foundation of trial design. Thank you for your watching. See you in the next video.